Hi, I'm George Woodbury from College of the Sequoias, and in this video we're going to do something interesting. We're going to work with the interest formula. If someone invests money in an account that pays 4% interest compounded continuously, how long will it take for their investment to double? So the formula that we use here is A equals P times E to the RT power, but in the last video, we talked about the model for exponential growth, and it really follows that same pattern, right? Y equals Y sub 0 e to the kt. Y sub 0 is the initial amount. The principal is the initial amount. The amount of times in the exponent in both. The ending amount is on the left side of both. But what's different is instead of that growth rate constant or growth decay constant, K, we have the interest rate R. But we work with it pretty much the same way. So this will go a little smoother or a little, Anyway, if someone invests their money, let's make a table, A, P, K, T. Oops, there I go with K again. This is interest rate. So I just copy the variables from the formula. If someone invests their money in an account that pays 4% interest, 0.04 for R, compounded continuously, how long will it take for their investment to double? So usually we're able to pick off 3 values in this problem and solve for the 4th. I only see 1 value in the problem. And what happens here is let's just let the initial principal be the variable P. We want to find out how long it takes to double. That's 2 times P. And the time is unknown. And it actually doesn't matter what amount we start with. You could have put 100 for P, then the amount at the end would be 200. Or you could have put 5 and 10, or 73 and 146. It doesn't matter because when we solve this equation, whatever we started with, the next line is going to look the same. Let me show you what I mean. Filling in for A, that's 2P equals PE to the 0.04 T power. I need to isolate the exponential expression, and to do that, I need to divide by P. And when I divide the left side by P, 2 times P divided by P is just 2. And so no matter what you started with for your principal, when you divide it over here, the double amount divided by that, so it's going to equal 2 every time. So this is a doubling time formula. 2 equals E to the R times T power. We need to take the natural log of both sides to get out of the exponent. So the natural log of 2 equals the natural log of E to the 0.04 T power. On the left side, that's just the natural log of 2, but on the right side, the natural log of E to some power is just that power. We finish by dividing both sides by 0.04. And there's a shortcut formula for finding doubling time. It's the natural log of 2 divided by the interest rate. Off to the calculator. Function natural log back to the main screen of 2 divided by 0.04. And we get 17.3 years. By the way, there's a rule called the rule of 70 or 72, depending on which book you're reading, but it gives you an idea for how long it takes something to double if you know the interest rate, or if we're talking about inflation or something like that. And so the basic idea is if you divide 72 by the interest rate as a percent, not as a decimal, that gives you an estimate of how long it takes to double. So 72 divided by 4 is 18. 17.3, I was pretty close with 18 with very little work, but that's all that is. That's an estimate. That's not an exact value. Some people use 70 instead. 70 divided by 4 is 17.5. In this case, that's a little closer, right? I think we use 72 because it has more factors. So 70 you can't divide by 6, but you can divide 72 by 6, etc. All right, anyway, that's doubling time with compounding continuously.